Hello everyone, today is day 9 for preparation. Okay, so what I did today was, first of all, I read this paper, HyperFast, Instant Classification for Tabular Data. Okay, so this work for classification problem and given a tabular data. Okay, so what we are doing here was, here we were already using a meta-trained hyper network and using this like pre-trained network, we actually were generating a parameters for a neural network which can solve our immediate problem. So another way we can say that we already have some already pre-trained model, and using that pre-trained model we will solve our current classification problem. So how we will solve it? Using that you are using that pre-trained model to generate parameters of the neural network, and using those weights parameters you will directly classify. We will just import the hyperfast and get the weights. Okay, so we have with the weights and the architecture, so we directly use the uh, our current classification data. We will have the data set, and we call this as a support set here. So we use this data set and p10 model and directly get our response. Okay, so we don't need to do the training. So there is a hyperfast novel method to solve classification tasks from multiple domain with a single forward pass of hyper network. Okay, great. I won't go much in detail. Okay, um, so basically this method outperform the current boosting methods. Okay, like cat boost, setup boost, and gradient boosting algorithms, and also it outperformed the AutoML, which was trained for 1 hour. Okay, great. So after that, I went for studying a bit about PCA, principal component analysis. Okay, so this is simply a dimensional reduction technique. Okay, dimensional reduction. Okay, so there is also a concept of curse of dimensionality. So it is easier to visualize if you can think of, let's say you have a data set, you have 10 features. So for each feature, there are various possibilities. Let's say there's a class A, B, C, D for first feature. Second feature, there is a numerical values which can vary from 1 to 100. For third, there are two classes A, B. For next one, there are 10 choices. The next one, 100,000 choices. So if you try to project all kind of possibilities in a space, there's a kind of, let's say, kind of, it will be like an ocean. Imagine it like an ocean. You are expanding it all the entire data set, all the possibilities are possible. Let's say you fill up, let's say, think of like all the pathways we have assigned. uh, First possibility of feature 1, first possibility of feature 2, first possibility of feature 3, and go 1 1 1 1, then you go 1, then 2, then 1 1 1 1 1 2 2 1 1 1, like all the possibilities. And these are all the possibilities, but the data set we are given are only certain, let's say 100 rows, 1000 rows, 10,000 rows. Like when we go for large number of features, so it is not practically, it is becomes very difficult for the model to train. Okay, so try to read it, then this will be easier because it will be difficult to explain for me. But think of in that way. मतलब you will project it like a ocean, and then actual the rows, number of rows is like some fishes present in the ocean. So if there's a very large large number of features, then this can be the case. It will be difficult for our ML to train. So we want to reduce the number of features. We want to project our lake, our ocean as a lake or a pond. Are you getting it? So things will be easier. I don't know if there is such an analogy. I've just made it up. Okay. Let me just move it. Okay. Okay. There is a concept of manifold learning. So this is simply kind of projection. Okay. We are projecting so to higher space to lower space or lower to higher. Okay. So this is PCA, peaceful computer analysis. Okay. So we try to find a hyperplane. You can say, let's give an example. So there is a 2D plane. We try to find a single plane, or you can say single axis, to get most information. So we can say here the variance is very high. Variance is reduced, variance is reduced. Okay, so this is called first PCA. If you go for finding the second PCA or second axis, we look for an orthogonal to this, like perpendicular. And the third one will be coming out of the paper, coming out of the laptop, like perpendicular. Ith axis is called ith principal component of the PCA. Great, great, great. So it can handle only linear data. So it is based on the matrix technique called SVD. Okay, I don't understand this part. I will look for it later in the future. Okay. Okay, great. Okay, number of components. Okay, मतलब कितने में how much reducing, say 2 axis or 3 axis or no more. And there are two like in syntax PC dot explain variance ratio. So first axis variance, second axis variance. Okay, and some total variance will be 100%, like 1. So we can look for that. In the third part there will be very low, 0.14. It was written. Actually 1.2. 84.2, 14.6, 1.2%. It is very low. We can neglect it, right? Okay. This was common attribute, explain ratio, and choosing how number of dimension. Okay, so here is keeping one of the method is keeping the variance 0.995%. Okay, that was elbow method, and there the things go slow down. We can pick that one. This is for compression. Okay, we have compressed our data set, and we want to reconstruct it. So it won't be 100% the same because we have while compressing we have lost some data. If you are paying 95%, then there is loss of 5% variance. Okay, so the difference is called reconstruction error. Great. And there is randomized PCA. Okay, so using stochastic algorithm to speed up the things. Okay, to find a person the first deep peaceful component complexity differs. Okay, so there is a case if AT is much smaller than n, so only then can we use. And it is written that in scikit-learn it already includes this concept. But you don't have to think about this. Okay, incremental PCA, it uses the mini batches. So if there is a huge data set and you want to perform PCA, you have to go for incremental PCA. Great. And also there's a in NumPy there was mem map class. You have to manipulate a larger store. Okay, as a kernel PCA. Okay, it helps us to handle the non-linear data. So, okay, so suppose there is like Swiss data set, Swiss roll data, like this one. So here it is not like you can't project it in a 2D plane or find a simple line or axis which can reduce the dimension. So there's a method we use called is kernel trick. This is kindly 3D. If you try to project in a 4D, 5D, and even with a high dimension, and then use linear PCA. Okay. So actually I looked over. Okay, this one. Explain kernel PCA and what is kernel trick in context of our confused with kernel. So this limitation of standard PCA क्या है? It fails for nonlinear data, like curved and serial pattern which I just shown. What is kernel? It maps data into higher dimensional space using a nonlinear function and then apply linear PCA into this space. Okay. Explain the kernel trick. Explain क्या है इसमें? No, very much. Okay, and then next I went for understanding the decision tree. We know decision tree. They have to have concept Gini impurity and Gini impurity and entropy. We will check the mathematical description, mathematical definition later. Random forest, we use multiple decision trees. Okay, multiple, and there's only subset of data with replacement grade, and there's also random selection of features. Both is there, random selection of data and features. Okay, then there is mean prediction or majority vote grade, and there is boosting method. Okay, ADA boost, what we do. Okay, we focus on the weekly misclassified sample. We give it a vote. Okay, we initially we solve like apply the random first model, whatever the descent, whatever thing are we using, and then we check. Okay, these are like our model misclassified these, so we'll focus on these on the next problem. Okay, the second step done. Okay, then focus on the remaining misclassified one. This process goes on. Repeat combining learners with weighted vote. Okay, then boosting by vote special. Okay, it fit new trees to residual errors. Cat boost. Okay, this is better. Adavo sample reweighting, gain optimization, histogram GPU support, categorical handling. Reweights specified sample ADA boost, GPU target the residual errors via gradients, okay, light GPM and cut boost, optimizations for speed and categorical data. Okay, the difference between entropy. So this is the mathematical formulation of entropy. 1 pi log pi. This is just, let's say, probability. Okay, great minus this is genuine purity. Okay, that's all for today. This was a very quick overview. I know I will forget all these. I just need to keep it on YouTube so I can check it later.